Before we start, let's have a quick drill first. Try this. Divide 4x cubed plus 2x squared minus 10x minus 11 by x plus 2 using long division method. Check your answer. Now notice that dividing a polynomial by a binomial or even by another polynomial seems to be a very long and taxing process. Now, is there a way for us to ease it up? Well, yes. And it's for this reason why our next topic came to fruition. We've been using long division to divide a polynomial by another polynomial, and the process is a bit tedious because of its repetitive steps. Now, is there a shorter way to do it? The answer is a big yes. So in this lesson, you will learn how to perform division of polynomials using synthetic division. So that shorter method that we're looking for is what we call synthetic division. Now, there's a shorter way when a polynomial is to be divided by a binomial of the form x minus r. This method is called synthetic division, also known as Horner's method. It is a shorthand method where we divide the coefficients of the polynomials, removing the variables and exponents. It allows us to add throughout the process instead of subtract, as we would do in traditional long division. Now, take note that this only works for divisors of the form x minus r. So your divisor must only be a binomial. Now remember that x plus r is just equal to x minus negative r. Now synthetic division is shorter since it only requires addition and multiplication of coefficients. Now let us have this example. Use synthetic division to divide 2x cubed minus 5x squared plus 3x plus 7 by x minus 2. Now, the first step is to arrange the coefficients of p of x in descending powers of x, placing zeros for the missing terms and write them in the first row. So, let's look at our polynomial dividend. The coefficients here are 2, negative 5, 3, and 7. Notice that there is no missing term here because we have x cubed term, x squared term, x term, and then the constant term. So we write the coefficients in the first row. Therefore, we have 2, negative 5, 3, and 7. Next step, place the value of r in the upper left corner. In this example, x minus r equals x minus 2. Thus, r equals 2. Now, another way of going about this is to equate the divisor here, which is x minus 2 to 0. Therefore, if x minus 2 equals 0, then x is equal to 2, and that is also our r. So here is the r. We put it in the upper left corner. Next step, bring down the first term of the dividend, then multiply it with the divisor. Place the product under the second term of the dividend, then add. So the first term of the dividend here is 2. So we bring it down and then we multiply that with the divisor. So 2 times 2, that is 4. So we place 4 here under the second term of the dividend. And then we add negative 5 plus 4, that will be negative 1. Next step, repeat the procedure described in step 3 until the last number in the third row is obtained. So again, bring down the first term of the dividend, multiply that with 2 here. So 2 times 2, that will be 4. Add, we get negative 1. Negative 1 times 2, that will be negative 2. Add, this will be 1. 1 times 2 is 2. Add, we get 9. Next step. The resulting values are considered as the coefficients of the quotient Q of x, whose literal coefficient is 1 degree lower than the polynomial dividend P of x. So take note that the degree of the quotient is 1 degree lower than the degree of the polynomial dividend. The final sum of the process serves as the remainder R of x. So the quotient here is 2x squared minus x plus 1, and the remainder is 9. So let's look at it again. So 9 here is the remainder. And these are the coefficients of the quotient. So 1 here is our constant term. It's positive, so we can now add the plus sign here. Negative 1 is the coefficient of the x term. So we can write x here. And 2 is the coefficient of the x squared term. That's why the quotient is 2x squared minus x plus 1. Now, we said that the degree of the quotient should be 1 degree lower than the degree of the polynomial dividend. Now, the polynomial dividend here has a degree of 3. Our quotient here should therefore be of degree 2. And the result can be expressed as P of x over Q of x equals Q of x plus R of x over D of x. This is our division algorithm. So the polynomial dividend is 2x cubed minus 5x squared plus 3x plus 7 all over x minus 2. This should be D of x equals 2x squared minus x plus 1, the quotient Q of x, plus 9, the remainder, all over x minus 2. So take note, this should be D of x, the divisor. Now the result can also be written of the form P of x equals Q of x times D of x plus R of x. Therefore, 2x squared minus 5x squared plus 3x plus 7 is equal to the quotient 2x squared minus x plus 1 times the divisor x minus 2 plus the remainder, which is 9. Now let's have another example. Use synthetic division to divide 3x cubed plus 4x squared plus 8 by x plus 2. So again, we arrange the coefficients of the polynomial dividend. Now notice here that there's a missing term in the dividend. There is no x term here. So therefore, we will place 0 to fill up that missing term. So the coefficients now will be 3, 4, 0, and 8. This 0 will be filling up the place of the x term because there's no x term in the given polynomial dividend. Next, place the value of r in the upper left corner. So, what is our r here? If you equate x plus 2 to 0, then you will get x equals negative 2. That is also our r. So, r here is negative 2. And then, next step, bring down the first term of the dividend. So, the first term of the dividend is 3. Bring it down and multiply that with the divisor. So, 3 times negative 2, that will be negative 6. And then add. This will be negative 2. Now, repeat the procedure until the last number in the third row is obtained. So, just repeat the procedure in step 3. So, again, bring down 3, multiply that with negative 2. The answer is negative 6. Add, that's negative 2. Multiply that with negative 2. The answer is 4. Add, that's 4. 4 times negative 2 is negative 8. Add, that will be 0. Next step. So here, this is our remainder. And these are now the coefficients of the quotient. Now take note that the quotient should be 1 degree lower than the degree of the polynomial dividend. So the degree of the polynomial dividend is 3. Therefore, the quotient's degree must be 2. Therefore, the quotient here is 3x squared minus 2x plus 4. R of x equals 0 since the remainder is 0. So the result can be written of this form. This is now our division algorithm. Therefore, 3x cubed plus 4x squared plus 8 equals 3x squared minus 2x plus 4, the quotient, times x minus 2, the divisor, plus 0, the remainder. Or we can simply write 3x cubed plus 4x squared plus 8 equals the quantity 3x squared minus 2x plus 4 times the quantity x minus 2. Another example. So find the quotient of x to the fourth plus 8x squared minus 5x cubed minus 2 plus 15x and x minus 3. So this should be plus 15x. Now notice that the dividend here is not in standard form. So there's a need for us to rearrange the terms of the polynomial. So rearranging, we will have x to the fourth minus 5x cubed plus 8x squared plus 15x minus 2. So this is our dividend. Now get the coefficients. So the coefficient of x to the fourth is 1. X cubed is negative 5. Coefficient of x squared is 8. Here it's 15. And then the constant term, which is negative 2. Our divisor is x minus 3. Therefore, our r is 3. So the divisor here in synthetic division is 3. So first step, bring down 1, the first term of the dividend, and then multiply that with the divisor. 1 times 3, that's 3. and then add. This is negative 2. Negative 2 times 3, that will be negative 6. 8 plus negative 6 is 2. 2 times 3, that will be 6. Add this, you get 21. 21 times 3, that is 63. Add, we get 61. This 61 here is our remainder. So since the degree of the dividend is 4, therefore the degree of our quotient should be 3. So the quotient here should be x cubed minus 2x squared plus 2x plus 21. So the degree of the quotient should be 3. It's 1 degree lower than the degree of the polynomial dividend, which is 4. So the remainder is 61. Now let's have a recap of what we have discussed so far. To get the quotient between polynomials and binomial divisors of the form x minus r using synthetic division, simply follow these steps. First, the polynomial p of x and the divisor d of x must be arranged in descending order of degree. In cases of missing terms, do not forget to insert 0. 2. Identify all the numerical coefficients of the polynomial dividend. For the binomial divisor, take the opposite of the constant term and arrange the coefficients in an array and place the constant term of the binomial divisor on one side. Next, bring down the first term of the dividend, then multiply it with the divisor. Place the product along the second term of the divisor, then add. 4. Continue doing the previous step using the new dividend until the last coefficient of the divisor. And 5. The resulting values are considered the coefficients of the quotient, whose literal coefficient is 1 degree lower than the polynomial dividend. The final sum of the process serves as the remainder. And the result can be expressed as, so the division algorithm form, p of x equals q of x times d of x plus r of x, where p of x is the polynomial dividend, q of x is the quotient, d of x is the divisor, and r of x is the remainder. This ends our topic on synthetic division. Let's have a break as you answer the exercises provided for you on the topic. Next up, remainder and factor theorem.